Hey everybody, in this lesson we are going to actually graph parabolas. Now you've done this in Algebra 1 and in Algebra 2 or in prior algebra classes, so we're just really going to kind of hit the highlights. There's a lot more in-depth info that we can go into, but we're just going to look for the vertex. We are going to look for the axis of symmetry, figure out the direction that the parabola opens, and then do a rough sketch of it. The one thing that's going to be new is we're going to graph a horizontal parabola instead of just the regular vertical parabolas. So from our prior lessons, we said that the plane is parallel to the edge of the cone. So that's what gives us the shape when we cut through our cone. And then some basic info comparing parabolas in the other conic sections. So each of our other conic sections have an x squared term and a y squared term, but for the parabola, only one of the variables is going to be squared. So either the x will be squared or the y will be squared. And I'll show you what those equations look like. So here are the graphs of the vertical parabolas, the ones that you've seen before many times in your prior algebra classes. So if it is a vertical parabola opening up, you'll notice that it says our a value, our leading coefficient, is going to be greater than 0, so it's positive. And then we have our axis of symmetry cutting through the x coordinate of the vertex. Okay. If our a value is negative, our graph is going to open down. Again, that axis of symmetry is going to cut through the x coordinate of the vertex, so x equals h. The equation for our parabola listed as a conic is going to be y minus k equals a multiplied by the quantity of x minus h squared. Now, in prior algebra classes, we would actually take this k value and we would add it to the other side of the equation, and then it would be in what we call vertex form. Okay, so our vertex is the opposite of our h value and the opposite of our k value when we write it in this format. All right, so a couple other things to know. If the x is squared, the x term is squared, but the y is not, then it's going to open up or down, depending on that a value being positive or negative. Our vertex, it's like getting a center, but we only have one point that this entire function is based off of. So h comma k are the opposite of those values in the equation, and then that axis of symmetry is going to be x equals h. Okay, when we look at the horizontal ones next, we'll make the comparison between the two forms. Okay, so here are the horizontal graphs, and we still have h comma k, we still have the vertex, but you'll notice our axis of symmetry is a horizontal line, y equals k, so it's the y value of the vertex. If our leading coefficient is positive, it opens to the right. If our leading coefficient of our a value is negative, it opens to the left. Here's the equation. We've basically just flip-flopped. Now it's x minus h equals a multiplied by the quantity of y minus k squared. So again, we're going to take the opposite of h, opposite of k to get us our vertex. Our axis of symmetry is going to go through y equals k, the y value of your vertex. And again, opening right if a is positive, opening left if a is negative. And then this is when our equation where the y is the only term that is squared. The x will be not. All right, let's go ahead and graph some. Okay, so our first example says y plus 5 equals negative 2 multiplied by the quantity of x plus 2 squared. So the first thing I want you guys to look at is figure out which term is squared, because that's going to help you with the direction that it's open. So the x term is in parentheses and squared, which means y is not. So if our y value is not squared, that means our graph is going to open up or down. So the next thing that we look at is that leading coefficient. Whatever's in front of the squared term, in this case it's negative 2. Since our a value is negative, that means we've got to have the vertical parabola open up or down, but if A is negative, our graph is going to open down. So you can always just kind of give yourself, hey, rough sketch, this is what it looks like when it opens down. Righty? Now we're going to get our vertex, same as we did for centers, of ellipses, hyperbolas, and circles. The opposite of the term with the x, the opposite of what's with the y. So our vertex will be the point -2, -5. And then because this is a vertical parabola, our axis of symmetry is going to cut through vertically, cut it in half so the left and the right are identical, which means we're cutting through the x coordinate or the -2 value of our vertex. X equals -2 is the axis of symmetry. Now, if you don't get the axis of symmetry until after you've started to sketch it, by all means, that's fine. Just list it whenever. All right, so we're going to plot our vertex at -2, -5. Cool, got that. Then we're going to sketch our axis of symmetry. It is vertical. So there's our axis of symmetry. Just draw a vertical dotted line right through it. Now, you can always use the table of your calculator, or you can substitute in particular x values and solve for the y. You're welcome to do that. The other thing that you can do is you can use this leading coefficient, that a value, and for the very first set of points after the vertex, you can treat it like slope. So if I'm treating this as a slope, I'm going to go down 2 over 1. So for my vertex, I'm going to drop down 2 units to the right one, and then I mirror that to the other side as well. So down 2 to the right one, put a point, and then down 2 to the left one and put a point. So there's my first set of points that I have mirroring each other across that axis of symmetry. There's a pattern to get the next set of points that I have plotted. You would actually go triple the value from the vertex that you did the first time, so we'd go down 6 over 1. And get those points. Again, you can use the table or substitute values in. And then we'll just sketch our curve as best we can. And there's your parabola. Great job. All right, we've got a couple more of these to do, so let's roll through. All right, here we are with number 2. Y minus 9 equals 2 multiplied by the quantity of x minus 8 squared. And we see that the y term is not squared and the x is. That means our graph is going to open up or down, just like the last one. Look at that leading coefficient. Our a value is positive, so our graph is going to open up. Yay, graph is going to open up. So there's a teeny tiny little rough sketch of our graph opening up. All right, find your vertex. Take the opposite of the h, opposite of the k to give us a vertex at 8, 9. So this one's going to be kind of off the graph when we sketch our points. And that axis of symmetry, remember our axis of symmetry for verticals go through the x coordinate of the vertex. So our AOS is going to be at x equaling positive 8. Sketch your axis of symmetry through that point at 8, 9, that vertex point. And yes, again, we're going to use that rate of change, that a value we get to use at one time, and mirror the images, those points off of the axis of symmetry. So from the vertex, I'm going to travel up 2 to the right one and put a point. From the vertex, go up 2 to the left one and put a point. There's my first set of points using that a value. And again, you can substitute in other x values, such as -6 and positive 10, and those would give you another set of points that you could plot to sketch your parabola. Great job. Okay, here we go with example 3. X plus 8 equals 2 multiplied by the quantity of y minus 2 squared. Okay, so this one has the x term not squared. That tells me it's going to be horizontal because the y squared is. So x is not squared gives me a horizontal one. And then we're going to look at that leading coefficient. Our a value in this case is positive. It's a positive 2. So since it's a positive 2, that means you guys are correct. Yay, you were already thinking it, I know. Our graph is going to open to the right. So things are a teeny bit different. when we sketch our graphs to the right. We're still going to get the vertex the same way though. So I'm going to take the opposite of the h, opposite of k, to give me a vertex at -8, +2. And then because it's horizontal, remember, I've got to use a horizontal line as the axis of symmetry. So that's a y equals, so I've got to use y equals k, or y equals 2, that y coordinate of your vertex, for your AOS. Plot your vertex at -8, 2, sketch the horizontal axis of symmetry through it. Here's the part that's different. We can still use this A value. You totally can use it, but our graph's not up and down, so it's not a regular slope of rise over run. It's technically the run over the rise. So we're going to use the reciprocal of our A value to get the first set of points. Okay, now do you have to do it this way? No, you do not. You can substitute in a Y value. You could substitute in a 1 for the Y, get the X value that corresponds. You can substitute in a 3 for the Y and get the X value that corresponds. Okay, so you can still do that, not a problem. I like to use this way, it's a little faster. So I'm going to use the reciprocal of A. If A is 2, its reciprocal is 1 over 2. Okay, cool. So that means I'm going to go up or down 1 and then over 2. There we go. Or you could think you're going to go to the right 2 and then up or down 1. Okay, do its reciprocal. So I've got my first set of points that I could sketch at -6, 1 and -6, 3. You can again substitute values, y equaling 0 and 4, to get the next set of points, or you can use that pattern of tripling that distance out from your vertex. So we have our vertex at 8, -2. The first set of points are 1 unit above and below, 2 units to the right. Sketch your parabola. You got it. We got one more, gang. We are almost done. Yay us. Number 4, x minus 1 equals -4 multiplied by the quantity of y plus 5 squared. Okay, just like the last one, the y term is squared, the x is not. So when the x is not squared, that tells me it's going to be horizontal. Look at that leading coefficient. That a value is negative, which means, you got it, our graph is going to open to the left. So our graph's going to open to the left. I'm still going to have a horizontal axis of symmetry. So I've still got that line cutting it horizontally as I go through. Okay. All right, determine your vertex just like we've been doing. Opposite of h, opposite of k would give us 1, -5. And again, I want that horizontal line, so I want the y value for my axis of symmetry. So the y value of the vertex is -5, so AOS is at y equals -5. Plot your vertex, sketch your axis of symmetry, and again, use the reciprocal of your A value. Okay, can you plot points? Yes. You could plot, or you could substitute in a value of -4 for the y and solve for x, and -6 for the y and solve for x, so one above, one below. Then you could do -3 and -7 and get those x values corresponding to your y's. You can also use the reciprocal of your A value, which would be -1 over 4. That negative just tells you you're going to the left. And so I should go to the left 1, or excuse me, move over and then out 4. So I'm going to go up and down 1 and then out 4 units. We would then triple that value if you wanted to see another set of points to get some more way out there. They're actually off the graph. That's okay. So this is a really long and skinny horizontal parabola. Great job with this lesson. Super proud of you guys. Make sure that you're practicing the problems on worksheet E. I believe there's 8 of them. It's a good amount. It's good practice for you guys. Let me know if you have any questions.